Hi everyone! We are now in Module 16, which is about probability using permutations and combinations. After watching this video, you are expected to solve problems involving probability using permutations and combinations. Let's have a pretest first for you to have an idea on how you are going to solve probability using permutations and combinations. I want you to solve each of the following problems and write the letter of the correct answer. For number 1, number 2, number 3, number 4, and number 5. Take note, you can always pause and play this video whenever you need some more time in answering the problems. Now let's check your work. For numbers 1, 2, and 3, and for numbers 4 and 5. Did you get a perfect score? It's okay if not, but you have to listen to the discussion of solving problems involving probability using permutations and combinations. Let's have a recap first. I want you to, for each of the following, indicate if it is a problem solving involving permutations, combinations, or neither, and then answer the question being posed. Explain your reasoning. For number 1, how many groups of 5 songs can be chosen from a list of 35 songs? How about number 2? The racing club organizes a race in which 5 cars, A, B, C, D, and E are joined. How many possible race results if there are no ties? And number 3, what is the difference between permutations and combinations? Let's check if your answer is correct. For number 1, that's 324,632. But how did we get that? Let's analyze. What did we use? Did we use combination or permutation? Let's check. Choosing 5 songs from 35 songs doesn't require an order. Therefore, we use combination. That is combination of 35 taken 5, and it's equal to 324,632. How about in number 2? The answer is 120. And how did we get it? We use permutation. And why is that? It is because it includes order, or order is required. We need first, second, third, fourth, and fifth for the race. Therefore, we use permutation of 5 taken 5, and that is equal to 120. So what is the difference between permutation and combination? We use permutation whenever there is an order, or order matters. We use combination if order is not necessary. I hope it's clear. To continue with the lesson, let us now have the following examples. For number 1, in a lottery, 3 numbers are chosen from 0 to 9. You win if the 3 numbers you pick match the 3 numbers selected by the lottery machine. Letter A. What is the probability of winning this lottery if the number cannot be repeated? For letter B, what is the probability of winning this lottery if the numbers can be repeated? How about letter C? What is the probability of winning this lottery if you must watch the exact order that the lottery machine picked the numbers? Let's start with letter A. How are we going to solve for this? Are we going to use permutation or combination, or neither? Since we are going to choose 3 numbers and it doesn't require an order, we'll just choose 3. Therefore, we're going to make use of combination. Therefore, that is combination of 10 taken 3, which is equal to 120, because there are 10 numbers to choose from. and we only need 3 numbers. Therefore, it is equal to 120. And since there is only one winning number, the probability is 1 over 120. If the number cannot be repeated, how about if numbers can be repeated? If so, it doesn't fall under permutation nor combination. So what are we going to do? It means if numbers can be repeated, that is simply 10 cubed. We have 10 choices at first, same choices in second, and same choices with third. That's why we'll have 1 over 1,000, the probability of winning this lottery if the numbers can be repeated. How about letter C? Since order matters, we're going to make use of permutation. That's permutation of 10 taken 3, which is equal to 720. And since there's only one winning number, that is 1 over 720, the probability of winning this lottery if you must watch the exact order with the lottery machine with the numbers. I hope I made the example number 1 clear. So let's proceed to example number 2. Rose has the options of selecting 3 novels for a literature course. The book list consists of 10 classics and 5 contemporary novels. Find the probability that all novels selected will be contemporary novels. Let's think first. Is this a permutation or a combination? Selecting 3 novels means order is not important. Therefore, we'll use combination. But we have to make sure that all novels selected will be contemporary. That is why we'll only get 3 novels from 5 contemporary novels, which makes it combination of 5 taken 3, which is equal to 10. How about without restriction? It's combination of 15 taken 3, which is equal to 455. The one with restriction is your numerator. The one without restriction is your denominator. Therefore, the probability is 10 over 455, or simply 2 over 91. Hope I made it clear. Let's proceed to example number 3. Combination law shows 10 digits. Find the probability that if the combination to unlock the lock consists of 3 digits, it will contain the digits 1, 2, and 3. Repetitions are not permitted. So since repetitions are not permitted, again, we'll have a choice between is it a permutation or a combination. That is actually a permutation. Why is that? Because order matters. You need to put the first code first, followed by the second code, and then the third code. Order matters. That's why we'll use permutation. Therefore, the number of ways 1, 2, and 3 can be used is permutation of 3 taken 3, which is equal to 6. And the number of ways to select 3 digits from 10 digits in order is permutation of 10 taken 3, which is equal to 720. Therefore, the probability is 6 over 720, or simply 1 over 120. Is it clear? I hope so. So to wrap it up, I want you to remember that permutations and combinations can be used to calculate probabilities. You just need to identify if the problem requires arrangement in order, we'll use permutation. If order doesn't matter, then we'll use combination. Then apply rules of probability. Please take note of that. For our valuing, in your journal, I want you to reflect on this. In solving problems involving probability, sometimes we need to choose between permutations and combinations to answer the problem correctly. How did you choose your career for your future? Do you think that what you have chosen will make you succeed? Explain and discuss it with your groupmates. You are now ready for the post-test. I want you to identify what is being asked in this question and write only the letter of the correct answer. for number 1, for number 2, for number 3, for number 4, and for number 5. Let's check if your answer is correct. For numbers 1, 2, and 3, here is the answer. For numbers 4 and 5. I hope you made a perfect score. It's a good job. We are now ready for the different activities. For our activity 1, let's practice. For our activity 2, keep practicing. For number 1, 2, 3, 4, and 5. And for activity 3, test yourself. 1, 2, 3, 4, and 5. Now let's check if your answer is correct. For our activity 1, let's practice. For our activity 2, keep practicing. And for our activity 3, test yourself. Thank you for listening. Have a good day. God bless everyone. Keep safe.